Hi, everyone. Welcome back or welcome for your first time exploring space today. My name is, again, Thaddeus. I work here at the Bell Museum in our planetarium. And today I'm going to be using a program called Stellarium to help explore our sky. And I have, in fact, come into the Bell Museum to do this. And I hope many of you get to join us here in the Bell and in our planetarium. And I'd also like to take the moment to acknowledge that the Bell Museum sits on the traditional and treaty land of the Dakota people, who, along with the Ojibwe people, are the indigenous peoples of this land, Minnesota Makoche, or Minnesota. In recognition of this fact, and to honor the Dakota people for their care and knowledge of this land, we actually waive our general museum admission for Dakota and all indigenous people. And we recognize the long history of colonization and the traumas that have occurred over hundreds and thousands of the past years that have shaped us and led to the land we have today. I'd also like to take this moment to recognize that many of you are tuning in to listen and learn about the new alien life that has been found on Mars. And so I'm very proud, very excited, thrilled to talk about that. I'm going to start very simply by saying, Happy April Fool's Day. All right. I'm hoping a lot of you realize that before you tuned in. It is April 1st, but do not despair. If you are excited about Mars and you want to hear more about it, I will be talking about it today. And I will take a moment as well in the Facebook chat. Amber will share a link to my screen that I'm about to share here, which is to the latest and greatest Mars missions going on and images and media that you can find from them. So right now we have many spacecraft on Mars, there are three really spacecraft, I guess, but many spacecraft orbiting around Mars as well. The newest is the Perseverance lander, which landed about a month ago. And on the Mars page, mars.nasa.gov, you can explore some of the really cool and amazing images and videos that have been sent back. Some as recent as just the past few days. There is that really, I hope at this point, very famous landing video as well that some of you might have seen of the touchdown. And if you get a moment here to look through these, I'm going to give a shout out here for in fact, what is April, which is the month of Ingenuity, because in the next month, NASA is hoping to fly a spacecraft on Mars. It's very cool. The Ingenuity quadcopter is first of its kind on Mars, really on any planet. It's on the belly, the underside of the Perseverance rover, and it's been moving into the position the past few days to actually drop off the rover and then start its flight. I'm sort of just stunned saying that. This flight won't happen at least until after the first week of April. So they're planning at least after April 8th. And oh my God, stay tuned for this. It's gonna be so cool. I'm gonna actually show you where to find Mars though. I'll switch over here to our program that I always use called Stellarium. Stellarium is a free and open source program that you can, in fact, get yourselves, stellarium.org. And I think we may hopefully put that in the chat as well, because I know it's always popular to look it up. All right.
Ed, can I interrupt for just a moment?
By all means.
I just want to let our audience know that we are having some spam issues in the comments, and we are working very quickly to block those and and delete those. So I'm going to pause for a moment on posting any kind of links in the comments. Hopefully everyone can just listen to you for a little while. And once we get everything cleaned up, we'll go ahead and post some more links for Stellarium and other locations.
Okay, great. So you all get to listen to me some more. That's great. We are, so I'm using this program. It's called Stellarium here. And the name is in the upper left. This is a piece of planetarium software, really. It's one of many different types of planetarium software. This one is especially made for everyday people like you and me to use. And I find it a really great resource for when I'm trying to set up and decide what to go look at in the night sky. I've got the date and time visible down at my bottom right. So it's set up, in fact, for today, in fact, a little bit later tonight for a couple of reasons. The first reason, and we are facing west here, so a big W in front of us. We're also set up here in Minneapolis, the Twin Cities. So this is what we'd see kind of if we were going outside tonight. Of course, we have to deal with light pollution and weather, so you won't always see all these stars, but you can still see a great deal. One of those things you can see is Mars. In fact, here at about 9:30, looking directly to the south, Mars is sort of just smack dab right there in front of you. It is going to be a nice, bright orange-red spot. And you might be able to tell where it is because in this case, it's an orange-red spot that doesn't have a label. And it's sort of right in the middle, top middle of the screen here. And it is right here, right near the constellation of Taurus, or the Bull. And we can see Taurus there looking very fearsome. Now, Mars here is going to be visible in our sky throughout the month. It will be changing its position in the sky. So if you go out every night at about 9:30, it will change where it is, its distance above the horizon, and it will also move, as it were, through different constellations. So it started there in Taurus in the beginning of the month. As we go all the way to the end of April, it will be near the constellation of Gemini, or the Twins. So you can use the bright stars Castor and Pollux to find the body of Gemini, from the head down to the toes here, Alhena at the feet, and that can help you narrow down that it's Mars. Again, it'll still be very bright, very obvious. Mars is very distinctive in the sky, but having those stars around does help as guideposts. Again, jumping back to the beginning of the month here, today, the horns of Taurus are right nearby Mars as well. And the V here of Taurus as well sort of points up to Mars. So many different ways to track it down. And Mars here, where we have all these robots, well, this is a planet that is worth exploring, as NASA has been doing. And one reason we do explore it is because Mars does seem like in the past, billions of years ago, it was a potentially habitable planet, a world that might have supported life. So in fact, Perseverance, the Perseverance rover's main mission, its real scientific goal is the astrobiology, is studying the environment of Mars and possibly looking for hopefully possibly some signs of ancient life, whether that's buried in the rocks and biosignatures, or in the samples it's collecting, that it will collect, that we'll get back here on Earth. So Perseverance is really going to help us answer this question. Was there ever life on Mars? Who knows? Stay tuned. Coming back to our sky here, I'm starting here at 9:30 tonight, both for Mars, but for another reason as well. In fact, if you go out tonight and you look to the west, so that's going to be in the direction the sun was setting, or that it did set here at 9:30, and here at, in fact, 9:27, you go around 9:27 and dress warmly, it's still a little cold out, just go out and look and get used to seeing the stars. They're going to, over the next couple of minutes, the stars are going to stay in the same place, at least as we see it. They're not really going to appreciably change. They'll just sit there twinkling away in the sky. But if you keep watching and you're looking a bit to the west-northwest, close to the horizon, you'll start to see something change. Now, at first glance, you might think, oh, there's a plane coming over. But it's moving kind of slowly, a little bit slower than planes do. Oh, well, it could be a plane that's far away. If you keep watching it, you'll see it slowly move across the sky. And you might realize already that the bright light you're seeing down here to the west-northwest, we'll get it moving a little faster. This little spotlight here, all right, we're trying to get it moving a little faster. This little spot is not a plane, but it is a craft. It is a spacecraft. It is the International Space Station. So tonight we have a flyover or passover of the ISS. It will start and be really visible starting around 9:28, but it should be visible for about the next 4 minutes or so. It's going to go from the west-northwest over to the south. And it will be this very bright light. One key distinction here that it's not a plane is that it won't be twinkling. So we won't have that same twinkling lights. It also won't be twinkling like a star as well. And of course, it'll be moving. Now, right now, the ISS, there are in fact 7 astronauts on board the ISS. If Amber gets a chance, there's a website that actually updates how many people are on board and the nationalities, where the astronauts are from. It is a really amazing spacecraft. Seeing it is always just cool. I mean, it's the size of a football field. It's traveling at 17,000 miles per hour above our heads. It's going around the Earth every 90 minutes. It is simply just cool to see and to think about what's up there. There are exciting experiments happening all the time on board the International Space Station. And in fact, just in the last few days, plans have been made, or they might have already done it. They're actually shifting one of the Crew spacecraft up there. I believe the Crew Dragon is being moved to a different port on it to help facilitate additional launches and supplies being brought up there. So there's always exciting stuff going on. In fact, there is a live stream of the ISS as well that you can find if you Google NASA ISS live stream, and you can actually see that video from the ISS in real time, or as real time as it gets for something that's hundreds of miles above our heads with a radio signal being transmitted back down to us. All right. So we usually start, I always start in the evening sky when I'm looking at the sky. That's what I'm used to. But there are some folks out there who, despite how weird it sounds, they love getting up in the morning. So this next little bit here, this is for you morning folks. The mornings of April 5th, 6th, and 7th are going to be great if you love planets and our moon. All right. I'm going to move around. I've moved us and jumped us a bit here. We've gone to the morning of the 5th, and we're here at about, we'll do about, we'll split the difference here, 5:45. So about 5:45 in the morning. And that's about, it doesn't have to be exact. You get out at 5:30, you get out at 6, you're going to see some of the same things. Getting out, of course, later than 6, you're going to get a lot of sunlight there from the rising sun because we are facing to the southeast here. So in fact, if you're going out in the cities, you might, or if you're just going out, you might already start to see some of the glow from the rising sun in the morning here. But as we look to the southeast, over these 3 mornings, April 5th, 6th, and 7th, there are 3 objects to pick out. First one, easiest one, is our moon. Our moon here is always a beautiful sight to see. And here at the beginning of the month, we are in fact the last stages of the moon. It is our waning gibbous moon. So it's getting smaller as it goes around the Earth, and less of it is being lit up from our point of view. And by smaller, I do mean we see less of it. The moon itself is not changing in size or in mass, which is good. If you track down the moon, look a little bit to the left of it, that's further to the east, coming in sort of a straight line over from the moon, you can find a bright point of light. And if you come down from that bright point of light close to the horizon, you'll find a second bright point of light. All right, what are these bright points of light? Well, they're not moving, so they're not the International Space Station, sorry. They're also not twinkling. Now, you may have noticed that, or you may have noticed that before if you've gone outside in the sky, that the stars twinkle, but some objects don't. Objects like planets. Mars back there in the early evening wasn't twinkling, and neither are Jupiter or Saturn. So over the next few days here, from the 5th to the 6th to the 7th, the moon is your guide to finding these 2 planets, because here on the morning of the 5th, it's further to the south. As we go forward one more day here to the 6th, it's now right below Saturn. And if we jump forward to the 7th, and we do go a little bit further in time here, it's now going to be below Jupiter. So the moon can help point you to these different planets. Now, going back just a little bit, and we'll get it a little bit darker here. If you do have telescope, binoculars, or just your own eyes, it's always great to look at these planets with whatever you've got. Binoculars are great. They'll give you a slightly magnified view of Saturn, a bright view. You might start to see it as a more of an oval shape because of that beautiful ring system. With a small telescope a few inches across, you might pick out some of the rings themselves. They're actually very easy to see. They're only 180,000 miles across, so they stand out there. You might also see some of the moons as well. Bright ones, Tethys or Rhea, Enceladus, and Titan especially stand out. Titan really stands out. One of the largest moons in the entire solar system. I believe actually that might be the 2nd or 3rd largest moon. I have to double check myself on that. Although I'm sure there's someone out there double checking me right now as I speak. Titan, though, is a very exciting moon to see because this is not only a large moon, about 2,000, a little over 2,000 miles across, it is a moon with an atmosphere. Now, this atmosphere that we see here is not oxygen like ours. It's actually made of carbon dioxide and methane. And that components in that atmosphere give it this beautiful orange color. Now, this orange is a little bit different from the orange of Mars. Before with Mars, we were looking at a rusted, rocky surface. With Titan here, we're just looking at the atmosphere itself. But with Titan and with the amount of methane on the surface and what's going on the surface, some scientists think that this might actually potentially be a habitable moon. There might be some form of methane-based life that could have developed on Titan. If that sounds a little too crazy for you, stick with Enceladus. This is my favorite moon in the entire solar system. And Stellarium will let me zoom in this much. It's a very small moon. It's only a couple hundred miles across. But it is very bright because it is an icy moon. This is basically like looking at Hoth, a cold, frozen, icy tundra of a surface. No atmosphere really to speak of. Well, some loose gases and water vapor, and frozen water, ice surrounding it. That frozen water, that ice, is actually coming from Enceladus itself. What scientists have found is that Enceladus has geysers of water that erupt out of the surface, and liquid water that erupt out of the surface. And that underneath the surface of Enceladus, there is most likely a liquid ocean. So another place where, yet again, there might be some form of life, or at least there's a possibility that life could develop there. All right, now, spent a lot of time there on Saturn. Don't worry, I have not forgotten that other planet because I know it's a favorite, Jupiter. And just to stick with that theme of life, though, this is another world, Jupiter, where we have multiple moons that you can see. The 4 Galilean moons, Ganymede, Europa, Io, and Callisto, are visible in a line here. And we have moons that could potentially support life. Europa especially is another moon that we've discovered that there is likely an ocean of water underneath the surface, as well as suggestions of the same thing on Ganymede and maybe even Callisto as well. Io here, a very small moon, well, still pretty big, a couple thousand miles across. Io is an incredibly rocky volcanic world or moon, although I think world fits everything here. And we can see that as we zoom in. There are, in fact, volcanoes that have erupted and spewed out different sulfur compounds across the surface. Even still, even though without probably any liquid water there, this might be a place where life can develop when we start to think about things like volcanic vents, where that source of heat is a source of energy and where the molecules and elements could maybe potentially combine together into something more exciting. Although if you're a volcanologist, that moon is already crazy exciting, I know. Okay. So we've gone to the morning here, something for you early morning risers. And even if you don't get out these specific mornings, don't worry. The moon is a great way over the 5th, 6th, and 7th to track down these planets, but they are, even just on their own, very bright. And if you're just looking at the morning sky here at 5:45 over the month of April, you'll see these planets. In fact, they'll be getting easier and easier to see as the month goes along. Well, you also have to go out early and earlier because the sun's going to start rising earlier and earlier. No, everything's moving in space. But as we go later into the month, Jupiter and Saturn will be higher and higher above the horizon. This is due to our changing position around the sun. So you'll see them more and more clearly. If you do get out at the right moment, this one's going to be a little bit more difficult to see. I'm going to go to 5 o'clock here at the very end of the month, move way over to the east-southeast, and with a telescope, you might be able to pick out the planet Neptune. Now, Neptune is pretty close to the horizon, and often here in the city, it does get blocked by trees, buildings, all this stuff around us. This has sort of burned me before. I've gone out looking for things because, oh, they're right there. Stellarium shows me where they are, but we have, the real world around us as well. If you can get to maybe the top of the building, or if you're further away from the cities, or if you have a large field around you, those are all ways that you can help help still see things that are close to the horizon. And Neptune is totally worth it. Again, you do need a telescope to see it, and it will look like this bright dot, bright round bluish dot. Oddly enough, this is also coming, or maybe oddly, just like with Titan, this is also coming from its atmosphere, this beautiful blue color, coming from a lot of carbon dioxide again, or excuse me, methane again in its atmosphere, which is scattering blue light back to us. Now, I won't guarantee that you'll see all the moons around Neptune that we see picked out here. Triton, though, very exciting moon, icy moon. And I virtually guarantee that with a backyard telescope, you won't see the rings of Neptune. You would need something like the Hubble Space Telescope to see that. As always, if you are looking at something with the Hubble Space Telescope, please let me know. I'd really, really like to be your friend. All right. There is so much more to talk about. Let's jump to about, actually, you know what? We're already here at the end of the month. I'll go backward just a few days again to, and we'll stick here in the early evening-ish, or excuse me, early morning-ish. Now we'll go back to 3 o'clock. Why not? 3 o'clock, nice and early or very, very late, either way you look at it. Something for late people who like to stay up late, your night owls and your early risers. And something to look for if you've got some good eyes and a couple hours probably. Because the morning of, or the days surrounding the 22nd and 23rd of April, we have the Lyriads meteor shower. The Lyriads is one of our annual meteor showers. So every year around this time it occurs. And the peak of it is on the night of, or morning of the 22nd, in between 22nd and 23rd. So the morning of the 23rd here, well, the time you see on the screen there, 22nd and 23rd. Now, if you're looking for the Lyriads and you don't get out this exact morning, or it's cloudy or it's raining, don't despair. Meteor showers are week-long, multi-week-long events. So if you get out in the days surrounding the 22nd and 23rd, you'll still stand a chance of seeing some of these meteors. And this meteor watching is a long-term thing. Again, a couple hours, maybe at least maybe half an hour. If you're going to budget your time there, at least half an hour. Because meteors are random, essentially. We know they're going to be there right in the middle of this stream of rock and dust that's hitting our atmosphere. But where they come from, the intensity of the meteors of the rock, how long they last, really up in the air, well, or up in space, as it were. So really a great way to see meteors is to get a blanket or a lawn chair. You know, it's still cold here, so bundle up warm. Go outside again, just sort of lie down and just look up. You don't want to use any equipment. You don't want to use any binoculars, no telescopes, just your own eyes, just looking up at the sky. And these meteors, again, will appear from sort of any direction. They get their name Lyriads, though, because they appear to originate from the constellation of Lyra, or the Harp. And if you're looking for that constellation, you're in luck. It's an easy one to find. Look here, here in the morning of the 22nd at 3 o'clock, we're looking to the southeast, and you'll look high up in the sky. In fact, even if you're sort of looking to the south, you'll look high up in the sky and look for a bright, bright white star. Now, there's a lot of stars that all kind of look bright white, right? That doesn't really stand out. Well, this will be the brightest star that you see high near the top of the sky. It's the star Vega. Vega is part of this constellation of Lyra. Very small constellation over here, Lyra. Just half a dozen stars or so, depending on how you connect things together. But it makes up, as the ancient Greeks saw, well, again, a harp. Although, honestly, the way I look at it, I always imagine usually there's another line sort of coming off from it over to, say, to this star here. And so you get something that looks a lot more like a juice box in the sky. That's how I see it. But the constellation, or excuse me, the meteors from the Lyriad meteor shower, again, will appear to originate from this part of the sky. So if you are watching long enough, you could actually track those meteors coming back to that one point in space. While you're looking at Vega, you might also track further down, head down to the east-southeast, and you could see the star Altair, which is a part of Aquila, or the Eagle. And if you head upwards from Altair, you could find the star Deneb, part of Cygnus, the swan, or the goose. Now, these three stars are already named here because they are very, very bright. And Stellarium names the brightest, labels the brightest stars So it makes it a little bit easier to track them down. And so these three stars connected together make up a large grouping called the Summer Triangle. Very easy to see, very easy to spot, visible throughout the summer months, even into the late fall, and here in the very early morning, very late evening here in the spring. But fair to say we are in the spring. So believe it or not, there is in fact a spring connection of stars as well. To find this collection of stars, you're going to spin around to, let's do the west. Well, actually, you know what? Let's come back to the early evening. This is, again, how I'm familiar looking at the sky. So we'll go with me for a second here. You can look for this next grouping in a variety of ways, though, and it's very easy to do because no matter what, you're going to look for the Big Dipper. Now, here I've gone back to 9:30, and I'll even go back to the middle of the month, just move things around. And I'm going to look to the east. So we can see that E at the bottom of the screen there. And I'm going to look for the Big Dipper. Now, if I'm looking to the east for the Big Dipper here at about 9:30 throughout the month, it's very, in a sense, very, very easy to find because I'm going to look way up near almost to the very top of the sky. Maybe not quite lying down on the ground, but I'm going to really crane my neck back there. And I'm going to look for something, a dipper shape, which you might be familiar with. But this dipper is made up of 7 stars. And here in the early spring months, the dipper is standing almost straight up and down with the handle lower down than the bucket. So if you haven't already picked it out, we have the Big Dipper right here, made up or part of the constellation of Ursa Major, or the Larger Bear. We can see the bear there. It's a cute constellation. Not as cute as the Little Dipper, of course, which is over here. Now, if you sticking with the Big Dipper though, if you take the Big Dipper and you take the handle of the Big Dipper, the 3 stars here, Alioth, Mizor, Alcor, and Alkaid, if you take these 3 stars and you follow that arc they make, if you follow it downwards, you can find the star Arcturus. And we call this in astronomy arcing to Arcturus. This arc here brings us to the brightest star of Bootes, or the herdsman, or the farmer. So this is another constellation in the sky that's seen by Greeks and Romans thousands of years ago. Although to me personally, kind of looks more like a giant ice cream cone. But I'm not sure they had that, so we can forgive them for not seeing that in the sky. But the nice thing about Bootes here is this ice cream cone shape is a very nice triangle or a spike. And if you follow the spike down from the stars of the head, Theba and Saginas, if you follow them down through Arcturus and you imagine a straight line coming outwards, you end up over at the star Spica. And Spica here is the brightest star in Virgo. Ooh. Or the maiden, or the goddess of the harvest. Virgo here in this constellation has been associated with harvest and springtime in many different cultures because this constellation is one that we just start to see here in the early spring months. And so it's been linked then seasonally to what's happening here on Earth. Although the stars themselves have really no effect on what's happening here on Earth, besides looking very pretty and being very nice to look at in the sky. But this last jump that we made here from Bootes down to Spica and Virgo, this is the making the arc. Well, we made the arc to Arcturus, and this is making the spike to Spica. So we start again at the Big Dipper here in Ursa Major, and we come down through the handle to Arcturus. We arc down to Arcturus, and then we spike on, or spike to Spica. Some of you might also know this as speed on to Spica. I've heard that one before. Now, this entire line here, if you can imagine it in the sky, this is known as the spring curve because it makes kind of a curve, and we see it in the spring months. I'm pausing here to let the cleverness of that one set in for y'all. Now, as you're looking here, there is a lot that we can see, a lot else that we can see in the sky that is very far outside these stars. In fact, everything we've been seeing here is all part of our Milky Way. But these stars that we're seeing, these are part of the Milky Way that's outside the main disk of the Milky Way. So if you've ever seen the Milky Way in the night sky before, the part that you've seen is the main disk of it, the brightest part, the part that we're right inside. you can kind of imagine the Milky Way like a pancake, and we're right inside that pancake. And so the bits that we see are the thickest part of the pancake. But the pancake of the Milky Way, which is actually a candy bar, I suppose. Oof, I'm confused myself here again. That pancake, though, we'll stick with pancake. That pancake has stars above and below it as well. So the Milky Way has a lot of stars scattered around. However, during the spring months, although the stars that we're seeing are part of the Milky Way, they're part of this more scattered bits. And we're actually looking outside the main disk. And so in this case, we get to look far outside our galaxy when we look for some other deep sky objects. The spring months are generally known as the months of the months of galaxies. So if you want to go galaxy hunting, this is the time of year to do it. Right near the head of Virgo, in fact, we have a grouping, deep sky object going to turn on. We have right in the arms of Virgo here near the head, we have a grouping known as the Virgo cluster. And I'm going to see if I can get the Virgo cluster to show up here. It's going to help me out. Look at that. Now, these are fainter objects, so I've had to increase what Stellarium says we can see here quite a bit. But all of these red spots are different galaxies that we can see. And here, in fact, we have a lot of them together because galaxies like to stick together. They like to cluster together. So the Virgo cluster is a popular target for amateur astronomers because we've got so many galaxies here. And so we've got a greater amount of bright galaxies. One galaxy in particular, here we go, is M87. M87 is a different type of galaxy from our own. I'd mentioned the Milky Way is kind of like a pancake. Well, M87 is like a giant soccer ball full of stars. It's an elliptical galaxy, so it's a spherical type galaxy. And M87 has about 1 trillion stars, give or take, in it. And so it makes it a very easy sight to see. Even at about 18 million light years away, or excuse me, 60 million light years away, 18 million parsecs, megaparsecs. M87 is a popular target for amateur astronomers. It's also very popular with professional astronomers, those who are doing a little bit more intensive work. In particular, M87 was imaged over the course of many years by many different telescopes all across the world as part of a joint effort to image a black hole. And just a few years ago, the Event Horizon Telescope did indeed do that. It gave us the first image ever of the area surrounding a black hole. Now, we've suspected there's a black hole there for a long time because one thing that we've seen from M87 is this jet of material coming outwards. This jet here extending out for tens of thousands of light years is from material ejected from the region surrounding the black hole at the center of M87. So if you get a chance to see that, you will need a telescope, but it's a very cool sight. Another cool galaxy, one more galaxy I'll point out, as we're reaching the end of our time, is down here near the constellation of Corvus, or the Crow. So if you found Spica, you can come overwards a little bit and you can look for Corvus. It's a very simple constellation. It's just 4 stars. I've also heard it described as a sail, like for a sailboat. And I can imagine that. Just gonna tilt my head a little bit. But it was imagined as a crow. These 2 stars here at the top, though, Jina and I'm not going to try to pronounce that one today. These 2 stars, if you find them in the sky, just to give you some context, they're about here. They'll point over a little bit further on. Imagine again, a sort of a straight line coming out here. And looking with a telescope, this is where you can find the antenna galaxies, or Caldwell 60. The antenna galaxies are, just simply put, one of my favorite galaxies to see in the night sky. Every time as we get into the spring, it cheers me up to know that they're there, along with our warming season here coming along. The antenna galaxies are a pair of interacting or colliding galaxies. So they're 2 galaxies that are actually merging together. This whole process started about 1 billion years ago. And because of this merger, there's a lot of star formation going on. Gas and dust is being stirred up. And we're seeing thousands, millions of new stars being born. And so that puts out a lot of light and allows us to see it. I've looked at it with a telescope before, multiple times now. And to me, if you can sort of see this, if you tilt your head, sort of squint your eyes, it looks kind of like a a bright little heart, a fuzzy little heart there in the sky. So, oh, again, always one of my favorites to see, the antenna galaxies near Corvus the Crow. Okay. I'm looking at my list of things to talk about, and there's so much more to talk about, but we are reaching the end of our time, I believe. So I guess I should check in. Amber, did we get a chance for anyone to ask any questions? We were dealing with some spam earlier.
Yeah, thank you, Thaddeus. Yeah, we did get that under control. And there were a couple of questions that came in. The first one that came in from Ellen was, she was wondering what the difference was between a moon and another celestial body.
Sure. So the difference between a moon and another celestial body. Well, strictly speaking, as the last time I checked, at least, I don't believe there's any formal definition for a moon, but we generally think of them as something that is orbiting around a planet. And a planet would be something that is in a round spherical shape, is going around the sun, and is collecting all of the objects around it like moons. So that would be the big thing that makes a moon a moon. It's going around a planet. Moons are also not generating any significant energy of their own. Bit of a qualifier there. So they're not fusing, at the very least, they're not fusing elements together and releasing light like a star is, for example. So stars are releasing immense amounts of energy, and a moon won't do that. Although they can be very energetic, as we saw earlier when I was talking about Io with all the volcanoes on the surface. All right, more questions, hopefully.
Yeah, the other questions I actually kind of grouped together, as is much the case in the last couple of months. There's a lot of interest in Mars and what's happening with the Perseverance rover. So we had a couple of questions from Christina and Raul, and I want to thank our audience also for posting some answers in the comments and helping to explain the mission a little bit more. They are wondering a little bit more about how samples are retrieved from Perseverance, and also what kind of tests are done to look for life specifically, and what we think that if there is life, what do we think it might take the form of? So lots of deep questions.
Lots of deep questions. So the first one was about how the samples are collected, correct? Yeah. So let's see. From what I've read about, there's a drill on Perseverance. And it will drill into rock or into the regolith, the rocky ground of Mars. And as that drill bit goes in, it's hollow in the center, kind of think of it like a straw. And it will go down, and then it will break off the sample of whatever is there, and it will bring it back to the rover itself. And it will actually put it inside it will be as part of a sample tube, and it'll go within a sample collection unit. So the sample tubes go within this larger collection unit. And then these sample collection tubes will be dropped off. So they'll actually be dropped off on the surface, and the rover will continue along its way. And this is really important because this then gives us the exact place and time that the samples were collected from. So then when they're brought back to Earth, we have that really good basic information. We're not guessing like, when did this happen? Now, the process of actually getting those back to Earth, that actually hasn't been formalized yet. There is no spacecraft as yet that has been built to collect those samples. The basic idea, though, is that there's actually not just one, but two more, sort of in a sense, three more spacecraft. So one more spacecraft will actually go to Mars and it will land on the surface. And that spacecraft will collect the samples. Along the way, it will probably be in an orbiter, and that orbiter will remain above the atmosphere of Mars, will remain orbiting around Mars. That might have an orbiter, or the next stage might have an orbiter. This next stage would again be going to Mars, would land on the surface, but in this case, its job would be to launch those samples off the surface and meet up with the orbiter again. So this could take the form of a few different spacecraft. That lander as well, that goes and collects the samples, could also have that launch system as well with it. But in either case, there's going to need to be something to collect the samples, and then launch them off Mars into something that will return them back here to Earth. That orbiter will probably, as we've done with other spacecraft, it will come back to Earth very slowly, fire its engines to get back to Earth, and it will probably drop the samples down to Earth's surface on a parachute. That tends to be the way we do it. It tends to be in a sense, the easiest way, although it is a very risky way. I don't want to understate that. It's gone badly sometimes. when we look for, when we analyze these samples, there's a few different things we can do. And this sort of gets this question of what might we be looking for? In fact, maybe I should answer that question first because it's an easy question because the answer is we don't know. Sorry. We're looking at another planet. If there was life there, maybe it is just like life here on Earth. Maybe life here on Earth, what all the various types we have, our DNA double helix, maybe that's very, very common. Maybe that's the easiest way for life to form. And maybe that's just what we should expect to find on Mars. Or maybe because it's an alien world, a totally different planet, maybe there's some other form of life. Maybe life doesn't use this double helix shape. Maybe it uses, or maybe it's based around methane, and it uses, say, maybe methane forms that in together into rings, and that allows a cell structure to be built or something like that. So life, as it were, could take many different possibilities. We're probably going to stick with some of the basic ones that we know. Everything I just said is great, but we'll probably stick with what we know about life here on Earth. After all, we know there's a lot of life on Earth. So, well, we can study it and we can compare it and we can then use that to study other places. And so one thing we might do is to look for biosignatures of life. So as life lives and as it dies, it changes the composition and the relative ratios of elements and molecules in objects, in like soil, objects like planets. I've totally blanked on the ratio that I want to mention for a fundamental biosignature. So I'm going to look that up and I'm going to put in the comments afterwards. But we're going to look for ways that life changes the whatever is there, say the soil of Mars, if it is indeed soil. Amber, I skipped on the last part, got away from me a bit. So maybe there's another question we can give a better answer to.
No, sure. Just to change directions a little bit, Shivam is wondering more about night sky viewing and if there's a configuration of binoculars that you recommend for that if one doesn't have a telescope.
There is, and oh man, there is. In fact, I helped. It's a pair of binoculars that I helped our store. I think my screen share stopped there. That we actually have here at the Bell Museum. And Amber, maybe we're gonna have to post that one in the comments. It's a pair of Celestrons. I want to say they're 15 by 70s. That sounds right-ish. And they're really great. They're a fantastic pair of fairly sort of medium weight binoculars, not too heavy, but not very cheap light ones. They give a great view that's, again, not super magnified, so not like a telescope, but give a slightly magnified view of the sky, which is a great way to study the sky, to learn it as you're learning about it. If you magnify it too much, if you get a really big telescope that with a really great eyepiece that gives you like 1,800 zoom or something, 800x, whatever, that's way too much. You're going to be looking at this tiny, you're going to be looking at like single dots and you'll be like, I have no idea what's here. Binoculars are fantastic because you get this wide view and you can put things in context. They're also really great for big things like the moon. If you want to look at craters on the moon, fantastic for that. Large star clusters are great. Yeah, and we'll get that link to the binoculars themselves in the chat so you can get an idea of that.
Okay, and one final question, just a follow-up question about moons from Christina. Yes. Christina's wondering if it's possible for planets like Earth to actually gather more moons over time?
Yes. Oh, I'm sorry, I'm giving long answers, right? That's what I do. Yes, it's, oh my God, this is so cool. You might actually hear about these sometimes. They get called, I think one common name is like mini moons. The Earth's mini moons, and they are there. They're these tiny little rocks that get captured by the gravity of the Earth. This happens, from what we can know, probably really frequently. They don't last very long. They can get tugged away over long enough times by gravitational interactions from the sun, but from the moon, Luna, Selene, are the moon we think of. But yeah, it's very, very, very easy for the Earth to do that. We don't expect to find a giant moon. We don't expect to find like another Luna in orbit around the Earth. That would be very weird. that would be a sign of aliens. If another moon suddenly showed up in orbit around the Earth, that would be a sign of aliens. But as our telescopes get better and better, as we start looking for things like these, now that we know that they're there, we're easily going to find, I'm going to go out on a limb and say hundreds of them over the next few years. Because because that's what the Earth does. One of the things that makes it a planet.